Geometry 7-1. You'll notice that I am recording with the camera on paper, which means you're going to need your compass and your straight edge. So make sure you have those handy as we get going today. We're going to talk about dilations. We're going to start with the Explorer and Reason. Roosevelt High School sells a sticker and a large car decal with the school logo. How are the sticker and the car decal alike, and how are they different? Take a moment, look at those pictures, and answer that question for part A. Hopefully you determined that they have the same design or shape. That's what is the same colors. You can list all of those things as well if you'd like, but the important thing here is that they have the same design. The size changed, but the design and shape all stayed the same. They are different sizes. And that's what's important about the differences. Suppose the sticker and decal are shown next to each other on a computer screen. If you zoom in to 125%, what would stay the same on the figures and what would be different? Again, the shape stays the same. And the size changes. We're going to look at it a little bit deeper as we go into dilations of what that actually means when the shape stays the same. We, of course, have a little bit of vocabulary here. We have pre-image and image. And my highlighters are not with me, but we're going to go ahead and box these. If you've got your highlighters handy, once again, I suggest highlighting definitions so that they're easy to find. So we have a pre-image, and this is basically our original shape. And then our image, which is the new shape, or it's the transformation of the pre-image. Pre-image. Hopefully this word transformation is familiar to you from earlier chapters. Example 1 asks us to dilate ABC by a scale factor of 1/2 with a fixed center of P. So dilations are enlargements or reductions, and this one is a scale factor of 1/2. So that means we're going to be making a smaller shape, and the fixed center is P, and that fixed center is called the center of dilation. Center of dilation. So we're going to use point P as our starting place for how to measure. We're going to make this half the size of the original triangle, ABC. I'd like you to start by making a straight line between A and P. I'm going to make mine dashed just because it's not part of the actual image that I'm trying to construct here. So I've got this line going between A and P. How can we make half? Well, hopefully you remember that I can cut this line in half by creating a perpendicular bisector. And for a perpendicular bisector, we need to recall that our compass should be open more than halfway. We're putting a marking And I'm gonna just try to mark at the top and bottom to keep our picture a little less crowded here. But I do need to make sure that they intersect. So they're gonna intersect here and here. And so really, I don't need this whole line of perpendicular bisector. I do need to know where that crosses so that I can be halfway between A and P. So my new point, A prime, is going to be right here. Let's go ahead and repeat that process for B. So we're going to start with a straight edge and draw our line between P and B. You may need to open your compass a little farther than it was before because you need to make sure it's open more than halfway, and this is a longer line. I need to go back. Not extend my line far enough. Here we go. And I'm using different colors because it helps me keep track of which markings went to which piece of construction. So between the green dots, I'm looking for that center of line PB, and it should be right there. That should be the halfway mark, and that makes it B prime. We repeat this process for C. I need a straight line between P and C. I need to make sure that my compass is open more than halfway. And we look for those points of intersection. They intersect here and here. So we're looking for where does that cross over that line, and it is right there. So right here will be C prime. Now I've created the vertices for the new triangle or the image. And I just need to connect points A, B, and C. There we have it. This triangle is now the same shape as the previous one. It is just half the size. As we keep things the same size, or the same shape, we notice that all of the angles are the same. The side lengths are different. We're going to go ahead and look at part B, and we're going to do one where we have a dilation by a scale factor of 3. So this time we're going to make it 3 times bigger. And that center of dilation is going to be R. And so we're going to make that 3 times bigger. We're going to start by drawing a line from R through K, and let's make it more than 3 times the length. So we just want to make sure that it's plenty long enough. So I went way up there. I'm actually going to redraw that line because I didn't go very straight. We want to be as precise as we can in these Constructions. It's a little better. I don't know why I can't get it through K. There, that's better. So try to be as precise as you can. What we're going to do now is we're going to use our compass as a measuring tool. We're going to open our compass to the width of RK. Now that I have the compass open to the width of RK, I need to make it 3 of those instead of 1. So there's 1, 2, 3. So K prime will be right here. Let's repeat the process between J and R. I'm going to open my compass to the width of JR. And I'm going to create 3 segments. 1, 2, 3. Making J prime this point here. Repeat the process for RL. Open the compass to the width of RL. And create 3 segments. 1, 2, 3. And L prime is right here. Now I can simply connect the vertices, connect the points to create the vertices. This is a very long one. My straight edge is almost not long enough here. And now the triangle J prime, K prime, L prime is 3 times the size of JKL. And we have kept the same shape and just created an enlargement. Go ahead and pause the video and do the try it if you feel confident that you can do so. Otherwise, I will walk you through the dilation. This time we're going to be doing a scale factor of 1/3. So ask yourself first, will this be an enlargement or a reduction? And this should be a reduction. Hopefully you've made that connection. 1/3 is smaller than 1, so we're going to be making a smaller shape. We don't have an actual construction that will work for this that we're going to worry about. So we're going to go ahead and we're going to draw the line between M and R. And we're going to go ahead and measure it. I'm going to use the millimeters because that's going to be the closest thing that I can get. That comes out on my measuring to about 84 millimeters. So 84 divided by 3. is 2.6 or 2 2/3. So we're kind of needing to figure out how many. Oh, that's why I have punched in the wrong buttons. That did not make sense. Divided by 3 is 28. That makes much more sense. So 84 divided by 3 equals 28. And so we're going to count over 28 millimeters. That's 10, 20, 5, 6, 7, 8. I can count over 28 millimeters from the other end as well. 10, 25, 6, 7, 8. So if I'm cutting my line into 3 equal pieces, you can check that by opening your compass to see and using that as a measuring tool. 1, 2, 3 pieces. And so we only want 1/3 of those. So we start at M and we go 1/3 of the way. And that will be our prime. The distance between M and P. Let's measure that. That is 40 millimeters divided by 3. It's going to be 13 1/3. We're going to just have to do the best we can. And it'll be about right there. And that will be where P prime is. P and Q. Is 86. Divided by 3 is 28 2/3. So we're going to go 28 2/3. Close to there. We want to be as precise as we can, but knowing that we are just drawing and measuring with the tools we've got, we know that this is not exact, but it is very close. And connect your points. And we know that PQR is a dilation, or P prime Q prime, R prime, is a dilation 1/3 the size of PQR. I would highlight here if you've got your highlighters handy. And we can solidify the concept for dilation. A dilation with the notation DNC is a transformation that has a center of dilation C and a scale factor of n. If n is greater than 1, then the dilation is an enlargement. And if n is between 0 and 1, the dilation is a reduction.